So the first intention is to actually understand the basic differential equation key concepts, like how a particular equation fulfills a differential equation, and how we can work backwards to get the general solution of that equation. So let's say a simple example here is that to be able to just verify that y equals to x cubed plus c is a general solution of this equation. So obviously, like when you differentiate this part dy by dx, we automatically get it is 3x squared, which is obvious, right? But the questions like such, I mean, this one where like you need to think about like a little bit more, is that we have to verify that this differential equation which you get, um, the general solution of this is this. So now when I do the derivative of the solution that I have got, so let's say dy by dx, it is c times e to the power negative x times negative 1. So dy by dx can be written as negative 1 times, and this is nothing but the y. So that's how you get. So you can see that you get the same derivative, which is out here. So obviously, if you look backwards, that okay, this was what I differentiated to get this. So if I want to find out the original function, this will be the solution. Now, when you say the general solution, now simply what does it mean is that if I look at the derivative dy by dx is minus y, so let's say if c to the power negative x graph is going to be something like this. Now, what does this C indicate is that there is no fixed value here. So there will be a general curves, like, it's not that just only one curve. It'll be a general solution. Like if C is negative, you get, so in that case, the general solution will be like this. So you in that case, you'll have um, lots of curves that might represent the general solution, depending upon the values of C. So logically speaking, when you talk about the differential equation, you need to understand that this. So to get the particular solution, until you get the particular solution, it represents the general solution. So to get the particular solution, you need to find out the values of C with the given condition of x and y. So for example, I'll give that the curve passes through 2 comma 5, and then one of the curve out of these curves, like infinite curves, become the general solution. I mean, becomes the particular solution. So this is the general idea about the differential equation. Let's take one more example. Now, for example, here has been given that y equals to negative 2 over x squared plus c. Show that the general solution of this differential equation is this. So we're not solving yet. We're not doing anything yet, but we're just going to differentiate this particular function. So to differentiate this, we obviously, like, let's say this is y is negative 2 over x squared plus c. So you're going to take this as negative 2 x squared plus c to the power negative 1, and then you differentiate this. So when I do the derivative of this, negative 2 times negative 1 times x squared plus c to the power negative 2, and then into the derivative x squared plus c, which is 2x. So this becomes negative positive 2 times this is 2x will become 4. This is going to be 4x or x squared plus um, c the whole square. Now they're saying that show that this is xy squared. So okay, I can just remove x out here. So x, if I remove, it is 4 over x squared plus c the whole square. And if I see that, if I square this, you get exactly the same thing, which is 4 over x squared plus c the whole square, which is nothing but, hence it is nothing but xy squared. So if I solve the differential equation for of I mean this differential equation, my general solution will be this. So this is just to set up the differential equation, like verify this is the general differential equation. So in logical sense, whichever way you're finding out the solution to differential equation or differential equation to solution, there is the reasoning behind into it, and obviously the reasoning is the antiderivative. So when you're solving any differential equation, you use the same concept of integration. So let us just try to understand and see how we can use the general um, uh, technique which we have learned previously to solve the differential equation. So the objective will be to cover up and understand how do we solve differential equations that are separable, and After that, we'll be solving something called as homogeneous. And we'll be using one method called as integration factor method to solve the differential equation. I have already the lessons on these ones, but still we'll take some different examples. So now let's say if we have the dy by dx is 2x minus y, show that y equals to 2x minus 2 c e to the power negative x is the general solution for this equation. So when I differentiate this equation, what we get is, if I have y equals to 2x minus 2 plus c e to the power negative x, the dy by dx term is going to be 2. The derivative here is 0 plus c e to the power negative x times negative 1. So what we get is, it'll be 2 negative c e to the power negative x. Now, since if I look at simply here, if I make c to the power negative x the subject, so if I make c to the power negative x the subject, what I get is y minus 2x plus 2. And if I plug in that value here, what we get is 2 minus y minus 2x plus 2. And if you open the bracket, it'll be 2 minus 2x minus y negative 2. So this cancels. This becomes positive. So it'll be 2x minus y. So yes, we could show that the general solution of this differential equation is 2x minus y. Now, what we have to do is we have to sketch the approximate curve when differential equation for this general solution when c is 0, plus or minus 1, and plus or minus 2. So what we can do is, for this we can use actually Desmos or your graphing calculator to find out the values and how does the exact equation look. So we are basically asked to find out the general curve when c is 0, c is plus or minus 1, and c is plus or minus 2. So when you look at here, simply like on your calculator, you could have done that. But if I take, in this case, if I take c as 0, it's a straight line. So then general solution is a straight line. And if I take c as 1 plus minus 1, if it is 1, it is like this particular curve. If c is negative 1, it is c is negative 1, it is going to be like this, the general solution. And if c is 2, this general solution in this case is like here. And if c is negative 2, the general solution once again is like this. So what can be generally thought about is that maybe when you look at this general solution is like, okay, it's becoming a straight line when c is 0, and when c is like positive number, let's say, I mean negative number, the general solution comes like this. And when c is positive, the general solution actually is coming like this. So this is like, this is the way differential equations behave. But now when you find out the particular equation or particular solution, one of the curve becomes the general solution, I mean the particular solution. So let's take the next example where it is more of the finding out the particular solution. So let's say when you have to find out the particular solution which passes through 0, 1, it means you just plug in x as 0 and y as 1. So it'll be 1 equals to negative 2 plus c times e to the power 0. So the general solution will be c equals to basically, in this case is 3. I mean, the general solution will be, the particular solution will be 2x minus 2 plus 3 e to the power negative x. So that's your particular solution for this particular differential equation. Now, next up, we are asked is find the equation of tangent to this particular solution when at basically 0, 1. So you already have the derivative function. And now since we have already got the value of the equation, you don't want to differentiate again and you get this because you already have the derivative expression. So dy by dx is nothing but you just plug in the x value. So 2 times 0 minus 1. So you get negative 1 as the slope. And then you do y equals to negative x plus c because that's, I mean, negative x plus 1 because it passes through 0, 1. So anyway, y-intercept is going to be 1. So this is how you use the general culminated ideas to solve this particular problem.